Hi dear all, welcome to Brilliant Qatar. Here we are going to discuss chemical bonding and classification of element chapter, grade 11 chemistry, most important chapter, chemical bonding and classification of element, chapter 3, chapter 4. The previous year questions and the most important expected type of question we are going to discuss from these two chapters, dear all. Let's start from question number 1. Hope you all are ready. Dear all, here is our question number 1. Which of the following would have a permanent dipole moment? Which one having a permanent dipole moment? Dipole moment, how to calculate based on the electronegativity. In order to answer dipole moment question, first of all, we should have a clear picture about their structure of the molecule. According to VSE PR theory, how to find the structure of a molecule. Dear all, first compound is given BF3. BF3 structure is what? Trigonal planar shape, right? Trigonal planar shape, BF3. And the second compound is given SiF4. SiF4, it's having a tetrahedral shape, right? Tetrahedral. Sorry, SiF4 and BF3. And the third compound is given as SF4. What is the shape of SF4, dear all? SF4, it's having a seesaw shape, right? Seesaw shape. And what is the last compound, fourth one? XEF4. XEF4 having a square planar shape. Square planar shape. This is the shape of these four molecules. Dear all, can you able to say which one having a permanent dipole moment? Can you say, dear all, which one having a permanent dipole moment among these two compounds, among these four compounds? BF3, SiF4, SF4, SF4, and then XeF4. Among these molecules, which one having a permanent dipole moment? Can you give an answer? Can you give an answer, dear all? Which one having a permanent dipole moment? Dear all, in this question, you can able to see fluorine is most electronegative, right? So fluorine is more electronegative, so they all cancel each other. So here dipole moment is what? 0. And tetrahedral geometry, you know that all dipole moment cancel each other. So here also dipole moment is equal to what? 0. And XeF4, dear all, these fluorine cancel each other. These two fluorine cancel each other. Here also dipole moment nu equal to 0. But in the case of the third compound, yes, but in the case of third compound, dear all, these fluorines, you see, these fluorines that are cancel. But what about this one, dear all? It is not cancelling. It's having a permanent dipole moment. Which one? Yes, option C is the correct answer. So dear all, among these four compounds, so first of all you draw the shape. That means according to VSE PR theory, first of all we have to write the shape of the molecule. Then you have to check which is most electronegative element. Accordingly you have to write the bond arrow like this one. The most towards most electronegative element, the electron shifted. So by the way you can able to calculate which one having high dipole moment and least dipole moment, etc., or which one is highly polar and non-polar, etc. So dear all, which is the answer? Yes, F4, where the dipole moments not all are cancelling each other. So SF4 is the correct answer. In the case of trigonal planar shape, tetrahedral shape, square planar shape, if the surrounded elements all are same, dear all, their dipole moment cancel each other. So answer is which one? Option 3, SF4. That's the correct answer. All right. Question number 2. In the case of alkali metals, the covalent character decreases in the order. Can you tell me what is the order of the covalent character? Come on, all of you. Which one having covalent character? Covalent character is explained by Fajans rule. Fajans rule. What is Fajans rule, dear all? Smaller the cation, larger the anion. Smaller the cation, larger the anion, it's having high covalent character, right? High covalent character. Smaller cation, larger anion, having high covalent character. So what can be the answer, dear all? Which one having highest covalent character among metal fluoride, metal chloride, metal bromide, metal iodide? What is the correct answer? Smaller the cation, larger the anion, greater covalent character. So which one? Is it option D? Yes, of course, option D, because it's iodide. You know, iodine having bigger size, so bigger the anion, higher the covalent character. Yes, iodine, bromine, chlorine, fluorine. Yes, option D is the correct one. Yes, good. Next one. Which of the following two are isostructural? Means which of the following pairs having same structure? Which one having same structure? Can you able to say, dear all? First compound, XeF2. You just check, dear all. You don't need to calculate the entire thing like if they're asking isostructural or not. Just to calculate their bond pair and lone pair on the central atom. If the bond pair and lone pair on the central atom is same, almost their structures are same. For example, Xe is the xenon is the central atom. You know, xenon is a noble gas, so they're having 8 valence electron. Yes or no? It is surrounded by 2 fluorine. You know, each fluorine need 1 electrons to complete their octet. So it having 2 bond pair and 3 lone pair. Its shape is linear shape. Which one? XeF2. It's having a linear shape. Dear all, let me consider the other species, IF2. IF2 minus, okay? You know, iodine, what is the valence electron? 1, 2, 3, 4, 5, 6, 7. What do you mean by minus? Add 1 more electron on the central atom. It is surrounded by 2 fluorine. Each fluorine need 1 electron. So dear all, tell me, dear all, how many bond pair and lone pair? There are 2 bond pair and 3 lone pair. See, same situation. 2 bond pair, 3 lone pair. So their structures are same. What, dear all? Linear is their shape. Yes, option 1. They are isostructural. So isostructural means what? They have same structure. Okay. Option A is the correct answer. You know, NH3, dear all, NH3, you know, trigonal pyramidal shape, whereas BF3 trigonal planar shape. You know, all are different one. Okay. Question number, which one of the following species does not exist? Which one of the following molecule does not exist? According to molecular orbital theory, MOT, if the bond order is 0, then the molecule cannot exist. Yes, what's the point, dear all? If the bond order is 0, molecule cannot exist. Please note the point, all of you. What do you mean by bond order? Bond order means it's a number of bonds between 2 elements or 2 atoms in a molecule. So bond order 0 means there is no bonds, so the molecule cannot exist. So let's consider how to calculate this one, dear all. Very simple. There is a shortcut method. You may study, dear all, up to 20 electron system, how to calculate bond order. Let me give you a shortcut method. Let me start from 8 electron system first of all. 8, 9, 10. Okay. Let's start from 8 electron. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What is this, dear all? 8 electron, 9, 10, 11, 12, 13 and 14. Then 15, 16, 17, 18, 19 and 20. Now, dear all, careful. These electrons, so what is this, dear all? These outer numbers are number of electrons. Let me write its corresponding bond order inside. Careful. 8 electron system, bond order is 0. Now you add 0.5 in each step. So we will get 0.5, 1, 1.5, 2, 2.5 and 3. Now you repeat the same numbers in the other side. So 2.5, 2.5, 2, 1.5, 1.5, 0. Easy. So outer numbers represent number of electron and inside the number represent the bond order. Then what about less than 8 electron system, dear all? Another theory. Or 8, 7, 6, 5, 4, 3, 2, 1, 0. Which means 0, 1, 2, 3, 4, 5, 6, 7. What about this electron system? That you remember separately as a order. They are 0, 0.5, 1.5. Just remember that order, all of you. 0, 0.5, 1.5. Repeat once again. 0, 0.5, 1.5. This is the order. So dear all, these are electron number and inside their corresponding bond order. So tell me, dear all, Be2 plus. You know, beryllium. Hydrogen, helium, lithium, beryllium. Beryllium atomic number 4. So Be2 means 8 electron, from which 1 electron already loose. Be2 plus 7 electron system. What is the bond order? 0.5. Yes, bond order is there, molecule can exist. What about Be2? Be2 means how many electron, dear all? 8 electron system. 8 electron system, see dear all of you, bond order is 0. Bond order 0 mean molecule cannot exist. So what is the answer? Option 2 is the correct answer. Careful all of you. Bond order 0 mean molecule cannot exist. So which all system bond order is 0? 8 electron, 4 electron, then which one? 20 electron. These kind of electron systems, if they given, blindly you can write that their bond order is what? 0. Okay, so answer is option 2. Next question. In a regular octahedral molecule, you know MX6. What is octahedral shape, dear all? MX, right? This is octahedral shape MX6, where how many XMX bonds with 180 degree present? Can you able to answer, dear all? In an octahedral shape or geometry, how many XMX bonds are there with 180 degree angle? How many are there? Dear all of you, can you say the answer? How many are there with 180 degree bond angle? Which one? 3. Okay, let us check it, dear all. Let's consider XMX, this one first. Yes, this is 180. One another we can consider XMX. Yes, 180. And one another we can consider XMX. Yes, 180. Yes, I think there are 3 XMX bond with bond angle 180 degree. Yes or no? So dear all, what is the answer? Option 1, 3 are there. Option 1, 3. So regarding structure, varieties of question we can expect. Okay, next one. In BRF3 molecule, what is the compound given? BRF3 molecule. In BRF3 molecule, the lone pairs occupy equatorial position to minimize which repulsion? You know there is a lone pair repulsion, lone pair bond pair repulsion, bond pair repulsion. You know very well, lone pair repulsion is 2 higher than lone pair bond pair repulsion, higher than bond pair repulsion. So they are all BRF3. Let me draw the shape of the molecule Br. You know bromine is a halogen, so valence electron is 7. It is surrounded by 3 fluorine atom, each fluorine required 1 electron, so they contain 3 bond pair and 2 lone pair. There are 3 bond pair, 2 lone pair. What is the shape? We can able to say it's having a T shape, BRF3. It's having a T shape or trigonal bipyramidal geometry. Now, in order to minimize which repulsion, they are existing in this way. Of course, yes, correct answer of is that is option 3. In order to minimize, you can able to see there is a lone pair repulsion and lone pair bond pair repulsion also. These two repulsions are too high. So in BRF3, why they located such a way means in order to minimize both bond pair, lone pair and lone pair, bond pair repulsion. Both of them is to minimize. Okay, answer is option 3. Next question. In which one of the following molecule central atom is said to adopt sp2 hybridization? How to calculate hybridization? It's so easy, dear all. BeF2. Let us consider BeF2. Which is the central atom? Be. What is the valence electron of Be, dear all? 2, because its valence electron means atomic number, you know, 2, that is 4 electrons are there. So configuration is 2. So beryllium valence electron 2. It is surrounded by 2 fluorine atom. Each fluorine required 1 electron. So this is the condition. So you can able to see there are 2 sigma bond. Now, how to calculate the hybridization? Dear all, hybridization is calculated by the sum of sigma bond and lone pair on the central atom. Hybridization is calculated by taking the sum of sigma bond and lone pair on the central atom. Tell me how many sigma bond on this beryllium? 1, 2. Yes, 2 are there. Is there any lone pair on beryllium? No, 0. So what is the total sum, dear all? 2. If the total sum is 2, dear all, what is hybridization? Mixing of atomic orbitals, right? So mix first two orbitals, S and P. So what's hybridization? SP. That's not our answer. We need sp2. Let us go to BF3, dear all. In BF3, boron is there. Valence electron of boron is 3. It is surrounded by 3 fluorine atom. Each fluorine required 1 electron. So total there are 3 sigma bond and no lone pair. So total 3. 3 means what is hybridization, dear all? sp2. sp2. Suppose the sum is 4. sp3. What is the sum is 5? sp3d. If it is 6, sp3d2. Like that. So this is the shape of the molecule and hybridization. So hybridization is calculated by the sum of what, dear all? Keep in mind, sigma bond and lone pair. So easy one. Option 2 is the correct answer with the hybridization sp2. Dear all, are you clear? Is these points are clear? How to calculate the hybridization and all? Hafiz, Sabin and all, the way of answering hybridization, is it the part is clear? Right, the next one. According to molecular orbital theory, which of the following list rank the nitrogen species? Alright, nitrogen species in terms of increasing bond order. I already give you a method, a simple method how to memorize the bond order without doing molecular orbital, the orbital diagram and all. Dear all, the species are they given N2, N2 minus, N2 2 minus. These are the species, right? You know, N2 molecule contain 14 electron. N2 minus contain 14 with 1 electron extra, that is 15 electron. And N2 2 minus means what, dear all? N2 contain 14, 2 minus mean add 2 more, that is 16 electron system. 14, 15, 16. Okay, let's go for the previous one. 14, 15, 16. Dear all, remember. 14, where is 14? 14, 15, 16. The corresponding bond orders, just check it all of you. 3, 2.5, 2. 3, 2.5, 2. So we can able to say 3, 2.5, 2. So we already got the answer, dear all. What is the correct order of their bond order? Nitrogen having greatest bond order, then N2 minus, then N2 2 minus. What is the correct answer, dear all? N2 minus, N2 2 minus. What is the correct answer? Option? Which is the correct answer? Option number? N2 greater, then N2 minus, then N2 2 minus. What is the correct answer? Option 2. Yes, that's the correct answer. So bond order, that table, dear all, please memorize it. It's very important. Next one. Which of the following is isoelectronic? You know, isoelectronic. Isostructural mean those having same structure. Isoelectronic means those having same number of electrons. So which one having isoelectronic, which means same number of electron? Very simple. Dear all, carbon dioxide, right? Carbon dioxide, carbon contain how many electron? 6 electron. And oxygen, O2 contains 16 electron. So 16 plus 6, that's having 22 electron system. Now, what about NO2? NO2, nitrogen contains 7 electron, O2 contain, you know, how many? 16 electrons. So is it same? No, these are not isoelectronic. This is 6 plus, which one? 16, and this is 7 plus 16. Just count the number of electrons, that's it. What about this system? NO2 minus, dear all, NO2 minus, nitrogen 7 electron, 2 oxygen 16 electron plus 1. Right, dear all? So 18 plus 6, that's equal to what? Sorry, 17. Right, 17. So it's having 24 electrons. What about carbon dioxide? Carbon 6 electron and O2 16 electron. So what about that? 22 electron. Are they isoelectronic? No. So what is the option, dear all? What can be the option? Is it option 3? Is it option 3? Check it all of you. Easy one. Is it option 3? Carbon 6 electron, nitrogen 7 electron, minus indicate 1 electron extra. Okay. So 7 plus 7, 14 electron system. What about CO? Carbon 6 electron. Oxygen 8 electron. Yes, it's having 14 electron. Yes, they are isoelectronic. Option 3 is the correct answer. It's a simple one, but careful about the charges and all, okay? If there is a minus charge mentioned, add electron. Positive charge mentioned, lose electron. Okay, yes, option 3 is the correct answer. They are isoelectronic. Next one. Which one of the following species has maximum number of lone pair or electrons on the central atom? Where is maximum number of lone pair? Consider the first compound XeF4, Xe. You know, xenon valence electron is 8 because it's a noble gas. Surrounded by 2 fluorine atoms, each of them required 1 electron. You can able to see there are total 3 lone pairs. Second one is H3O plus, hydronium ion. Oxygen is the central atom. Oxygen valence electron, you know, 6, but plus indicate 1 electrons loosed, so that is around 5 electron. It is surrounded by 3 hydrogen atom, so you can able to see there is only 1 lone pair. And what is XeF4? Xenon again is the noble gas. Its valence electron is 8, surrounded by 4 fluorine atom. Each of them required 1 electron. So total there are only 2 lone pair. What about the last one, dear all? XeF6. Of course, it's having very lesser lone pairs, right? XeF6 means, dear all, the 1, 2, 3, 4, 5, 6. 2, 5, 6. All of them taken by fluorine, only 1 lone pair. So which one having greatest number of lone pair? Very good, dear all. Which one? Option 1. Especially xenon. Xenon is a noble gas. 8 electrons are there. If less number of surrounding elements, if it attached, what happened, dear all? Definitely lone pair numbers are higher. Right? Easy one. Next question. In a chemical change from PCl3 to PCl5, what is the hybridization of phosphorus changes? Dear all, PCl3 when changes to PCl5. PCl3 when changes to PCl5, what is the change in their hybridization? Dear all, phosphorus is the central atom. Phosphorus valence electron, you know, 5 because it's a nitrogen family element. It is surrounded by 3 chlorine atom. Each chlorine need 1 electron. So total there are 3 sigma bond. And what about this case, dear all? Phosphorus valence electron is 5, surrounded by 5 chlorine atom. Each chlorine required 1 electron, so they complete their octet. You know, hybridization is calculated by the sum of what? Sigma bond and lone pair. Tell me, dear all, how many sigma bonds are present on this phosphorus? 1, 2, 3. 3 plus only 1 lone pair. So total sum is what? 4. 4 mean mix first 4 orbital, sp3. So what's hybridization, dear all? sp3. What about this case, dear all? How many sigma bond? Total there are 5 sigma bond. Is there any lone pair? No. So total sum is 5. 5 mean sp3d. sp3d, that is the configuration or the hybridization. So sp3 become sp3d. sp3 become sp3d. What is option, dear all? Option 3. Yes. Simple, dear all, simple, but we should have a idea about VSEPR theory. That means how to determine the shape of a molecule, how to find the hybridization of a molecule. According to molecular theory, molecule can exist or does not exist. What is the bond order, whether paramagnetic or diamagnetic, what is the stability order, how bond length varies, dipole moment, resonance. These are the main part in which chapter? Chemical bonding. Anyway, we can go to the next one. The geometrical arrangement and shape. They are asking you what is the geometry and shape of the molecule I3 minus. Can you tell me, dear all? The one with I3 minus. What is the geometry and shape? What is the geometry and shape? Dear all, which is the central atom? Iodine. You know, iodine is a the halogen. It has 7 valence electron. Minus indicate it add 1 more electron. Now 2 iodines are surrounded. Each iodine required 1 electrons to complete their octet. You can able to see there are total 2 bond pair and 3 lone pair. 2 bond pair, 3 lone pair means we can able to draw in this way. Dear all, sorry, it's both are iodine, right? Iodine and 3 lone pair like this. Dear all, what is the difference between shape and geometry? when you calculating the geometry, you have to consider both bond pair and lone pair, how they located. Means you can able to see dear all, it is just like a trigonal bipyramidal. So geometry is what? Trigonal bipyramidal. Trigonal bipyramidal. But when you considering the shape of the molecule, just to consider only the bonds. Only the bonds. See, the bonds are located linear shape, right? Linear shape. So when you calculating the geometry of a molecule, consider both their lone pair and bond pair, how they located. But when you calculating the shape of the molecule, only consider the bond pair, how they located. So what is the answer dear all? Trigonal bipyramidal and linear shape. That is option number 1. Yes. Hope it is clear. Let's go to the next question dear all. The species having bond angle of 120 degree is. If you want to able to say where is 120 degree, the ammonia, water bond angle and all, we should have a proper idea about the shape of the molecule. The molecule is given pH3. Dear all, pH3, that structure is trigonal pyramidal shape like NH3. ClF3, it's having a T-shape molecule, ClF3. Now NCl3 is like NH3, that is having a trigonal pyramidal shape. And BCl3, BCl3, BF3 having a trigonal planar shape. Where you can observe dear all, there is a bond angle 120 degree. What is 120 degree? Here you can able to see this is 180 and this is 90. pH3 and all, it's lesser, very 93 like that, very lesser because of lone pair, bond pair repulsion. Even this also lesser. And NCl3, ammonia and all 107, that range. You can able to see 120 in only one option, which one? BCl3. Total is 360, right? 120, 120, 120. Total 360. So here is the bond angle, which one? 120 degree. Option 4, BCl3, BF3, trigonal planar shape molecules having, what is the bond angle here? 120 degree. Okay, option 4 is the correct answer. Next one. The correct shape and hybridization for XeF4 are. Tell me dear all, what is the answer? What is the answer dear all? Who can give it first? What is the correct shape and hybridization for XeF4? Come on first. I'm waiting for your answer. What is the correct shape and hybridization for XeF4? I think here correct structure is enough. Correct structure is enough because the beginning structures all are given different one. Structure is enough. I think automatically hybridization will be the correct one. Dear all, xenon is the central atom. Its valence electron is 8. It is surrounded by 4 fluorine atom and each fluorine required 1 electron. So total you can able to see that there are 4 bond pair and 2 lone pair. 4 bond pair, 2 lone pair means dear all, it's having, what is how to draw that way, 4 bond pair and 2 lone pair, XeF4, right? This is the 4 bond pair and 2 lone pair. Dear all, when you consider in the geometry of a molecule, you have to consider both the bond pair and lone pair. You can able to see the bond pair are square and lone pair up and down. So we can able to say it's square bipyramidal. It's also called what? Octahedral shape or geometry. We can able to say option 1 is the correct answer. Octahedral shape. And what is hybridization? Hybridization is calculated by the sum of sigma bond and lone pair. How many sigma bond on xenon dear all? 1, 2, 3, 4. 4 plus how many lone pair on xenon? 1 and 2. Total is equal to what? 6. 6 mean mix the first 6 orbital. We will get yes p3d2. Yes p3d2 and octahedral is the geometry. Option 1 is the correct one. Dear all, are you clear? Are you clear this question? Yes, Hafiz. Very good. Yes, there is a mistake. What is the mistake? They are asking the shape. They were asking the shape. Very good. If they are asking the geometry, then only option A is correct. Okay. Here they are asking the shape. When they are asking the shape of the molecule, we have to check only their bond pair, how they located. How the bonds located here all? That is just a square planar. Yes, very good. Square planar. Square planar, and hybridization is saying what? sp3d2. Of course, option is what? Option 4. Very good. Square planar is the shape. Geometry only octahedral. Okay, good. Next one. Predict the correct order among the following. This is one of the postulates of VSEPR theory. What is the correct the magnitude of the electron-electron repulsion in lone pair and bond pair? What is the answer here all? What is the correct order of the bond pair, lone pair, lone pair, lone pair, their repulsion pattern? Dear all, according to VSEPR theory, lone pair repulsion is greater than lone pair, bond pair repulsion greater than bond pair repulsion. So what is the correct answer? That is option D. Yes, fourth one. Lone pair, lone pair, lone pair, bond pair, bond pair, bond pair repulsion. It's one of the postulates of valence shell electron pair repulsion theory. Next one. Consider the molecule methane. What is methane? CH4. You know, structure is tetrahedral in shape and geometry. And next is given ammonia. You know, ammonia, NH3. It's having a trigonal pyramidal geometry or tetrahedral geometry and trigonal pyramidal shape. And H2O, you know very well, H2O is bend in shape or V shape. You know the bond angle in each case, I think dear all. What is normal tetrahedral bond angle? Normal tetrahedral bond angle 109.5 degree or 109 degree 28 minutes. Ammonia bond angle is 107 degree because of lone pair bond pair repulsion. It's shorter than tetrahedral. You know, water bond angle is again shorter because of lone pair repulsion. That's 104.5 degree. So question here all, which is the incorrect statement? Read all of you. I think the enough data is already given. Just choose the correct answer. Which one is incorrect among this one? Which one is incorrect among this one? Which is incorrect? Option 1, HOH bond angle in H2O. HOH bond angle in H2O, yes, it's 104.5 degree. Is larger than HCH bond angle. No, no. It is smaller. It is smaller than 109, right? So option A is the incorrect statement. There are all these points, this bond angle, memorize, okay? What is the normal tetrahedral bond angle? 109.5 degree. Ammonia bond angle, 107 degree. Water bond angle, 104.5 degree. Next one. A molecule having maximum dipole moment among the following is? Which one having maximum dipole moment? I think this one you can able to answer easily. Which one having maximum dipole moment? The structure, let me just tell you dear all. Carbon dioxide, you know, linear in shape. Methane is tetrahedral in shape. Tetrahedral in shape. Ammonia, it's having trigonal pyramidal. And NF3, that's also trigonal pyramidal. Which one dear all? Which one having higher dipole moment? Yes, very good. They're all linear shape, their dipole moment cancel. Tetrahedral shape also, their dipole moment cancel. NH3, NF3, yes, they have dipole moment. You know, NH3 when you consider, nitrogen is more electronegative. So resultant is upward. All are adding up. Whereas in NF3, lone pair, but fluorine downwards. There is some cancellation. So which one having greatest dipole moment here all? NH3. NH3 and NF3, when we consider, dear all, NH3 having highest dipole moment because all dipole moments are adding up. Whereas in NF3, there is some cancellation because lone pair upward, fluorine pull downward, right? There's some cancellation. So option 4 is the correct answer. Sorry, option 3 is the correct answer. Yeah. Next one. The angular shape of ozone molecule consists of. In ozone molecule, the shape, how many sigma bond and pi bonds are present? I think it's an easy question. You can able to answer. Tell me, dear all, how many sigma bond and pi bond present in an ozone, their angular shape? You know the shape of ozone is bend shape where there is a double bond oxygen and single bonded oxygen. You know, this is the shape of which one? The ozone, where is sigma, pi and sigma. So total there are 2 sigma bond and 1 pi bond. 2 sigma bond and 1 pi bond. The answer is which one? 4. Remember, ozone bend shape, 2 oxygens with a double bond, other oxygen with single bond. Next one. The ions O2 minus, F minus, Na plus, Mg2 plus, Al3 plus are isoelectronic, which means they contain same electron. Their ionic radii show. There all the species are given O2 minus, then F minus, Na plus, Mg2 plus, and then Al3 plus. Remember all of you, anions, according to the size of the cation and anion, we can able to say anions are bigger than cations. Anions are bigger than cations. So you can able to say these are anions here, they are bigger in size. Among O2 minus and F minus, which is bigger in size, dear all? O2 minus is bigger than F minus, which mean in the case of anion, among anion, greater the charge, greater the size. So O2 minus is greater than F minus. But in the case of cation, as the charge increases, size decreases. So we can able to say Na plus bigger size, then Mg2 plus, and least one Al3 plus. This is the order of the size of their ions. So which one is correct, dear all? Their ionic radii show. Can you able to say an answer? Can you able to say an answer based on this data, dear all? An increase from O2 minus to F minus. No. From O2 minus to F minus, there is a decrease. Option B, a decrease from O2 minus to F minus, an increase from Na plus to Al3 plus. No, there's also decrease. Option 3, a significant increase from O2 minus to Al3 plus. No, a significant decrease from O2 minus to Al3 plus. Good, dear all. Option 4 is the correct one. Read all options very carefully, okay? Maximum try to avoid mistake. Now, what are lanthanides? Tell me, because you just completed board exam, you have studied D and F block element, where you studied lanthanoids and actinides in F block element. What are lanthanoids? Correct definition here, or correct elements. Lanthanoids are, what's the correct answer? Hafiz, Sarim, Abin, Sriveda. What is the correct answer? Lanthanoids are, yes, lanthanide, you know, atomic number 57. After lanthanum, 14 elements are arranged in a separate row. They are starting from cerium to lutetium. Cerium to lutetium with atomic number 58 to 71. They are called what? Lanthanoid. And lanthanides are, you know, they are called 4f series element because their last electrons are entering into 4f orbital. Whereas actinoids are, after actinium, 14 elements are there. They are starting from thorium to lutetium. That's around, there are 5f series elements. So what is the correct answer, dear all? Is it option 4? 14 elements in the 6th period. You know, lanthanides are in 6th period, actinides are in 7th period. Okay, starting from 58 to 71. Yes, they are filling in their 4f sub level. Yes, correct answer is option 4. Next one. What is the correct order regarding the electronegativity of hybrid orbital? Come on, all of you. What is the correct order regarding the electronegativity of hybrid orbitals of carbon is? You know very well what is the electronegativity order. Yes, sp, sp2, sp3 hybridization. What is the s character? You know very well. In sp hybridization, you know 50% s character and 50% p character. In sp2 hybridization, 33.3% s character, remaining 66.6% p character. In sp3 hybridization, only 25% s character and remaining 75% p character. So what is the order of their electronegativity? How electronegativity related to s character, dear all? You know, higher the s character, higher the s character, high electronegativity. Higher the s character, high electronegativity. So sp having greater than sp2 then sp3, higher the s character, high electronegativity. So what is the correct answer, dear all? Option 3, right? Yes, sp, sp2, sp3. Higher the s character, highest electronegativity. Careful. Next one. Which one of the following order is not correct? Which one of the following order is not correct? I am giving you 1 minute. Read all option. Tell me a correct answer. Which one is not correct? Which one is incorrect from the following? There are option 4 you can able to understand easily. I think it's a most familiar one. You know, fluorine, chlorine, bromine, iodine. Yes, that is the correct order of their electronegativity. You know, fluorine is the most electronegative element. That's a correct one. It's a correct one. What about HI, HBr, HCl, HF, acidic property in water? You know, dear all, HF, HCl, HBr, HI. You know, while you coming down the group, the halogen size is bigger, the bond is weaker, you can remove hydrogen easier. Hydrogen easier, if you can remove, that is most acidic. So down the group in hydrogen halide, acidity increases. That's also correct one. Next one. Fluorine, chlorine, bromine, iodine, oxidizing power, whether which is an oxidizing agent or not. There are oxidizing agent mean they can undergo reduction. Reduction mean they can gain electron. Fluorine is the most electronegative element. Yes, they can gain electrons. So that is also the oxidizing power. Bond dissociation energy. What is bond dissociation energy? Amount of energy required to break the bond. If you consider fluorine and chlorine bond, we are expecting fluorine bond is too strong because fluorine are more electronegative. Yes, they are more electronegative, but fluorine bond is, dear all, it's weak. Fluorine bond is weak, not strong. Why? Because fluorine is a small element where all electrons are very close, so there will be larger electron repulsion. What's the point, all of you? Fluorine is a smaller element, so small elements mean all electrons are very close. So what happened? The electron repulsion is too high, therefore the bond is weak. Remember, fluorine bond is too weak than chlorine. So fluorine, they mention here, fluorine having high bond dissociation enthalpy, which means there is more energy required to break the bond. No, it's wrong. They're all option 1 is the incorrect order they mention. Careful, okay? Next question. Identify the correct order of the size of the following. Can you able to say, dear all? I told you anion, cation, which is bigger and all. Dear all, this is the correct order. Anions are bigger than neutral element. Neutral element in the sense parent element. Then cation is too smaller one. So according to this point, can you be able to say which is the correct order of the size of the following? This is the question from classification of element chapter, easy one. Dear all, which one? Among anion, I told you, as the charge of anion increases, their size also increases. But in cation, as charge increases, size decreases. So dear all, which one? S2 minus, greater, yes. Then Cl minus, then argon, then it means neutral element, then come to cation, K plus and Ca2 plus 1. Dear all, the point is, anions are bigger. Among anion, as the charge is greater, the size also greater. But in cation, when charge increases, size decreases. Okay, option 1 is the answer. Very good. Next one. Identify the correct order of the size of the ion. Right, that's the question we just discussed now. Which of the following orders of ionic radii is correctly represented? Which of the following order of ionic radii, same thing, is correctly represented? Which is the correct order of the size? Which one, dear all? Which one? Option A we can cut, because anion okay, but neutral one should come second, least one cation. Okay, not correct. Here fluorine and oxygen. Oxygen should come first, right? Because it's a greater charge. This is also wrong. Option 2 you are suggesting, okay, yes, anion having greater, in which higher the charge, higher the size, then cation. Yes, option 2 is the correct one. Yes, option 2 is the correct one. So remember the order, dear all. Anions, then neutral element, parent element, and then cations. Now, Be2 plus is isoelectronic with which of the following ion? First of all, Be2 plus how many electron? Even these are some small numbers, there is a chance to make mistake, okay, careful. Beryllium having 4 electron, 2 plus mean 2 electron gone, so 2 electrons left. So which one having a 2 electron system? Which is a 2 electron system? Come on fast all of you, easy. Which one having a 2 electron system? Which is isoelectronic. Hydrogen having 1 electron, hydrogen plus indicate it's no electron, 0. Lithium atomic number 3, from which 1 electron loose, yes, 2 electrons. So what is the answer, dear all? Lithium plus, right? Option 2 is the correct answer. Next one. For the second period elements, what is the correct increasing order of first ionization enthalpy? It's a NEET 2019 question. For the second period elements, what are second period elements, dear all? You know, hydrogen, helium, first period elements. You have lithium, beryllium, then you have boron, carbon, nitrogen, oxygen, fluorine, and what we have? Neon. So they're asking you, in the second period elements, what is the correct order of their first ionization enthalpy? You know, ionization enthalpy is the amount of energy required to remove an electron from the outermost shell. Smaller the size, what are the factors affecting ionization enthalpy? Smaller the size, high difficult to remove electron, so smaller the size, high ionization enthalpy. Second, higher the stability, half filled or fully filled stability, harder to remove electron, again high ionization enthalpy. Smaller the size and high stability make high ionization enthalpy. Keep that point in your mind. Now let's go. Which is the correct answer, dear all? Of course, neon is the first one, because neon is highly stable and it's a noble gas. It's harder to remove electron. Neon is first, no confusion. Next one, we can go to fluorine. Of course, fluorine is the most electronegative element. They are not ready to lose electron, fluorine. So neon and fluorine, that is okay. After neon and fluorine, which one can be suggested here all? Can you tell me oxygen and nitrogen, when you consider, which one having highest first ionization enthalpy? Can you able to say that, dear all? All of you, can you suggest in the chat box? Nitrogen and oxygen, when you consider, which one having greater ionization enthalpy? Oxygen, check the configuration, all of you, very important. Oxygen and nitrogen, careful, okay? Dear all, oxygen is 1s2, 2s2, 2p4, 8 electron. Nitrogen is 1s2, 2s2, 2p3, 7 electron. Where is high stability, dear all? Where is high stability? Yes, dear all, nitrogen is half filled. Nitrogen is half filled, its stability is too high, it's harder to remove electron. So nitrogen having greater than oxygen, careful. Nitrogen, oxygen, careful. Nitrogen having first ionization enthalpy greater than oxygen because nitrogen is half filled. Okay, that's over. Then we can go to carbon. Then boron and beryllium, there is a special case. Can you able to understand here all? What is beryllium? 1s2, 2s2. What about boron? 1s2, 2s2, 2p1. Which is more stable? Which is more stable? Beryllium, because it's fully filled. So it's harder to remove electron from beryllium and boron. Careful. Beryllium come first, then boron, then lithium. This is the correct order of their ionization enthalpy. So which all points you have to careful here, dear all? Nitrogen and oxygen, nitrogen is first because nitrogen is half filled. Beryllium and boron, beryllium is first because it's fully filled. Careful. So what is the correct answer, dear all? What is the correct answer? Neon, fluorine, nitrogen, oxygen, carbon, beryllium, boron, lithium. What is the correct answer? What is the correct answer? Neon, fluorine, nitrogen, oxygen, carbon, beryllium, boron, lithium. Which one? Option 2, right? Is it option 2, dear all? Are you clear? Are you clear? Are you clear the reason why nitrogen, oxygen we interchanged or beryllium and boron that we interchanged? Is it clear, all of you? Sivida, Ibn, Sarim, Hafiz, everyone, Ibn. Is the point is clear? Nitrogen and oxygen, beryllium and boron. Hope these points are clear. Okay, let's go to the next one. What is the correct order of increasing dipole moment? What is the correct order of their increasing dipole moment? Let's see the structure of the molecule here all. BF3. You know, BF3 is trigonal planar shape where, you know, all the dipole moment cancel each other. Dipole moment here it is 0. Second compound is given H2S. H2S, H2O, same structure, dear all. H2S and H2O, same structure. It's having bend shape. It's having bend shape. 2 bond pair, 2 lone pair. Here also 2 bond pair and 2 lone pair. But among these two, which one having greatest and the least dipole moment? You know, sulfur and hydrogen, when you consider, sulfur is more electronegative, and you know, lone pair pull in that direction. Resultant is upward. Yes. Oxygen is more electronegative, lone pair pull upward. Resultant is upward. Yes. These having high dipole moment. Among H2S and H2O, which one having greatest dipole moment? Dear all, only the difference is what? Here sulfur, here oxygen. Oxygen is more electronegative than sulfur. Oxygen is more electronegative than sulfur, so their effect will be more. So we can able to say H2O greater, then H2S, then BF3. So what is the correct answer, dear all? Option A is the, or first one is the correct one. Careful, okay? H2O is more dipole moment because of having high pulling effect, high electronegativity. Okay, next. Which of the following molecule is formed by sp2 hybrid orbital? Where you can able to see sp2 hybridization. Dear all, methane structure is tetrahedral shape. Tetrahedral mean total 4 sigma bond, no lone pair. 4 sigma bond mean sp3. The hybridization is sp3. But question is sp2. What is carbon dioxide? Carbon dioxide, you know, linear shape. In carbon dioxide molecule, you can able to see that what is the hybridization, dear all? Hybridization is given by the sum of sigma bond and lone pair. How many sigma bond? You know, sigma, pi. Total 2 sigma bond and no lone pair. What is the total sum? 2. 2 mean hybridization is what? sp. What we need? sp2. Let's go for option 3. Option 3 is given BF3. Careful all of you. BF3. BF3 means BF3 trigonal planar shape. Total how many sigma bond? 1, 2, 3. So 3 plus. Is there any lone pair on boron? No. So total is 3. 3 mean sp2. Yes, here we have sp2 hybridization. Option C is the correct answer. What about BeF2, dear all? Central atom beryllium. You know, beryllium valence electron 2 surrounded by 2 fluorine. There are total 2 sigma bond. So total is what? sp hybridization. Okay, so the one with sp2 hybridization is which one? BF3. Option C is the correct answer. Clear? So this is the way, or this is the type of question you can expect from which area? Chemical bonding and molecular structure, and even from classification of element. Once again, I am reminding all of you, from the chapter chemical bonding and molecular structure, please concentrate on these points. VSEPR theory, that means the structure determination. Second one, molecular orbital theory, where they will ask you what is a bond order, whether molecule can exist or does not exist, whether it is paramagnetic or diamagnetic, what is the stability order and all. Keep this point in your mind here all. Bond or some topics you have to be memorized. If the bond order increases, bond order is increases. What is meant by bond order? Number of bonds between two elements in the molecule. When you consider hydrogen molecule, hydrogen is connected through one bond, so bond order is 1. Oxygen is connected through a double bond, so bond order is 2. And nitrogen is connected through triple bond, bond order is 3. So bond order is nothing but the number of bonds between two elements. How bond order related to bond length? You know, single, double, triple, which is most strongest bond? Triple. So as the bond order increases, bond length decreases. You know, stronger the bond, shorter the length. So bond order is inversely proportional to what? Bond length. Careful all of you. As the bond order increases, bond length increases. Next point. How bond order related to the stability of the molecule? Here hydrogen, oxygen, nitrogen. Which is more stable? Nitrogen, because there is a very strong bond. So as the bond order increases, we can able to say stability of the molecule also increases. Okay, bond order increases mean stability also increases, but bond order is inversely proportional to bond length. How bond order related to bond dissociation energy? What is bond dissociation energy? Amount of energy required to break the bond. You know, stronger the bond, more energy we have to apply, right? So as the bond order increases, more bond energy required. So bond order is directly proportional to bond dissociation energy. Now some question you can expect from the hydrogen bonding. You know, there are two type of hydrogen bond, intermolecular and intramolecular hydrogen bonding. Example everything careful. Now dipole moment question. If you want to answer dipole moment question, we should have a clear picture about the structure of the molecule. Okay, the structure by using the dipole moment all you can calculate. We can able to remember that if the shape is linear, trigonal planar, tetrahedral, square planar, octahedral, in these cases if the surrounded elements are same, all their dipole moment maximum cancel each other, they are non-polar species. Which all species dear all? Where dipole moments are cancelling? Linear, trigonal planar, tetrahedral, square planar, octahedral. These cases their maximum there dipole moment cancel each other. And valence bond theory is there. The formal charge calculation is important. Formal charge calculation and some other we'll discuss in the classes. Formal charge calculation and resonance structures, resonance stability, and they will give you a compound and they will ask you how many sigma bond and pi bond in the compound. These kind of question we can expect from which area? Chemical bonding. Classification of element chapter. What is the group number? What is the period number? Lanthanoids, actinides, the trends. You know, what are the trends in periodic table? Atomic size, ionic size, the metallic character, non-metallic character, electronegativity, electropositivity, electron gain enthalpy, their oxidation state, and all the trends in the periodic table is most important. Focus on that. And they will ask you what are the general characteristics of S block, P block, D block, and F block elements. These are the area we were studied in which area? The classification of element. Even the beginning portion of the classification of element chapter, don't leave it all of you. Which one? Doberan's triad, the three triads and all, and the masses, and Newland's law of octave, Mendel's periodic table, and the latest one, Mosley periodic table. The every concepts, the NCERT point of view, please try to revise all these points once again, and let us discuss again in the another session, another chapters. So all of you keep practicing and wish you all the very best. Thank you all. Bye.
Good morning.
Good morning. What's all this? Your results. Congratulations to all. I'm confident you'll all achieve your goals. So young man, what are your aspirations?
I want to do robotics, ideally from the Bust Institute in the US.
And you, young lady?
Sir, I love kids and I would love to learn pediatrics. I feel Boston is the best place for that.
Sumit, what about you?
Back home to India for medicine.
Good. I'm sure you'll all achieve your aspirations, be it in India or anywhere. Keep in mind, your first challenge is the entrance, whether it's IIT,
J,
SAT or NEET. You have to learn from the masters. Brilliant Qatar is the passport to your success.
we undertake coaching for regular and repeat batches and tuition for board examinations. Brilliant Education Centre, Doha, Qatar.